Good morning, students. Today our topic solutions of first order first degree differential equations. Solution means we have to write the expression in terms of dependent and independent variable which has to satisfy the differential equation. So we have to write the answer in terms of x and y. That is the solution of the differential equation. So see that first type we are moving to the variable separable method. So according to the variables, we have to separate the terms. Then we are going to integrate. If we integrate, we can write the expression in terms of x and y. Okay, you see that exercise 10.5, first problem. If F is the constant force generated by the motor of an automobile of mass m, its velocity v is given by m dv by dt is equal to F minus kv, where k is a constant. Express v in terms of t, given that v is equal to 0 when t is equal to 0. So in this, you consider this equation, m dv by dt is equal to F minus kv. So first, it's what is the dependent variable and what is the independent variable, what are constant we should know. Here m, you see that F is the constant force generated by the motor of an automobile of mass m. So m is a constant and F is the constant force. So here F, in this problem it is a constant, and already they have mentioned k is a constant. So m, F, k, they are constants, and v is depending on t. Okay, so you have to write the expression in terms of v and t. So what we have to do, we have to separate the v terms in one side and t terms in another side. So that only we are going to do. So for that, m into dv, you see that here we can't split, so you just bring F minus kv to the next side, it will come in the denominator. And here you are having dt, so the dt should come to the numerator. Always dv dt, so it should be in the numerator. Okay, so the variables of integration should be in the numerator, and you have to integrate. You see that one side v terms are there along with the constant, another side t terms is there, so you are going to integrate on both the sides. So integral m dv divided by F minus kv is equal to integral dt. So here m is a constant, it is taken out, it is in the form of dx by F minus kv. So it is the linear term is there, that is integral dx divided by ax plus b if you have. So you will write the answer as 1 by a. So the coefficient of x should come in the denominator into log of ax plus b plus c. So this is the answer. Here instead of x you are having v is there. So therefore instead of x you are having b. So m is a constant, it is taken out. It is in the form of dv divided by ax plus b. So see the coefficient of v, that is minus k. So the minus k should come in the denominator, and if you integrate, your answer is log of F minus kv, and that is equal to integral dt is t and the constant of integration is plus c. Okay, so we have to arrange the expression. So it is minus m, see minus m, so in the denominator minus, I have written in the numerator minus m. The k has to be taken to the right side, so therefore kt plus kc. Okay, and you take this constant to the next side, it will come in the denominator. So the minus, it is in the form of m log a. So m log a means log a power m. So the minus 1 2 will go to the power minus 1 is equal to kt plus kc by m. So this can be written as, you see now, um, f minus kv the whole power minus 1 can be written as 1 by f minus kv. But this log, when you take it to the next side, it will come as an exponential function. So e power kt plus kc by m. If you split this as e power kt by m into e power kc by m, base or same, if you want to multiply you have to add the power. Here addition is there, so we have separated. So 1 by f minus kv is equal to, you see now, this is a t here, the variable is involved, so e power kt by m. You look at this, this is a fully constant, so we can take that constant as c. So c is a arbitrary constant. Here also you are having the constant totally, so this constant can be written as c. And what is given, that v is equal to 0 when t is equal to 0. So you are going to substitute v as 0 and t as 0. So when you substitute v 0 here, it is 1 by f, that is equal to c into, if you substitute 0 t as 0, 0 into anything 0, so e power 0, e power 0 answer is 1, so c is equal to 1 by f. So that has to be substituted here. So 1 by f minus kv is equal to, in the place of c you have written 1 by f e power kt by m. So this f, when you bring it to here, it will come in the numerator, and this f minus kv, when you bring it to the right side, it will in the numerator. So we have written f is equal to f minus kv e power kt by m. This is the expression in terms of v and t. Okay, so we'll go to the problem number 2. See that the velocity v of a parachute falling vertically satisfies the equation v dv by dx is equal to g into 1 minus v squared by k squared, where g and k are constant. If v and x are both initially 0, find v in terms of x. From this word it's clear, v in terms of x, that is v is depending on x. So v and x are variables, the remaining are constants. So you consider the expression, differential equation v dv by dx is equal to g into 1 minus v squared by k squared. G is a constant and k squared is also a constant, because it is given where g and k are constant. So only the variables are v and x. Okay, so v dv by dx is equal to g into, you take LCM, so it is k squared minus v squared by k squared. So what do we have to bring? One side we have to bring the k v terms, another side x terms. So v dv has to be kept in the dv, dx should be in the numerator. So v dv is kept in the left side. And what is the v term here? It is k squared minus v squared. Bring it is in the numerator in the right side. Okay, bring it down to the left side. So k squared minus v squared is equal to, what is remaining? G by k squared. And the dx here, if you bring it to the right side, it will become in the numerator. So g by k squared into dx. So one time left side fully v term, and the right side you are having x term. So integrate on both the sides. So if you integrate, see now here k squared minus v squared. So without a differentiation, so k squared, the differentiation of k squared is 0, because k is a constant. And if you differentiate this, what has to come? Minus 2v. So here v is there, so we have to multiply minus 2 on both the sides. Okay, so why we are doing like this? We have the formula integral, already you have studied in 11th standard. So that is f dash of x by f of x dx. Okay, so the function is in the denominator, whose differentiation is in the numerator, means you can write the answer as log of f of x plus c. What is it? Log of f of x plus c. So that only we are going to do. So here the differentiation of k squared minus v squared is minus 2b. but b alone is there, so we need minus 2, so we multiply minus 2 on both the sides. So here also it is multiplied. So now it is in the form of f dash of x by f of x. So if we integrate, the answer is log of f of x. So your f of x is k square minus v square, and minus 2, what is a constant? G by k squared is a constant. Here what is remaining? Integral dx. If you integrate dx, that is x plus c. Okay, so the next step, k square minus v square, the log, when you take it to the next side, it is e power. So e power minus 2g by k squared into x plus c. So it can be written as multiplication. So e power minus 2gx by k squared into e power c. E power c is a constant, so it is taken as c. And what is given? That v and x are initially 0, or both initially 0. So when v is equal to 0, when x is equal to 0, you substitute. In the place of v, it is 0, and here in the place of the power, e power, you are having x. So in the place of x, if you substitute 0, it is e power 0. So therefore e power 0 is 1. So c is equal to k squared. So c has to be substituted here. So when you substitute, it is k squared. You see, minus v squared, when you bring it to the right side, it will become plus v squared. So bring this k squared term to the left side as minus k squared e power minus 2gx by k squared. So v squared is equal to, from these two terms, if you take k squared out, so the first term you will have 1 minus, this is taken out, so here e power minus 2gx by k squared. So that is the expression for the second problem. And the third one, find the equation of the curve whose slope is y minus 1 divided by x squared plus x, and which passes through the point 1, 0. Find the equation of the curve. So we have to find the equation of the curve whose slope is given. So if the slope is given, we can write that as dy by dx. Slope usually we will denote as m. So m is equal to, in the differential calculus we have learned, m is equal to dy by dx at the point. Okay, so the slope is given, so therefore dy by dx is equal to y minus 1 divided by x squared plus x. So here y is depending on x. Okay, so we have to bring the terms, y term one side and x term another side. So here dy should be in the numerator. Here what is the y term? It is y minus 1. So bring it to the denominator, and this dx will go to the numerator in the right side. So dx divided by x squared plus x. So now what you have to do? You have to integrate on both the sides. Before going for the integration, so this x squared plus x term has to be written as a perfect square. Okay, so for that, what you have to do? So x squared plus x, you have to make it as a completion of square. For that, I have written the variable x. Here what the sign here you are having, you have to write the sign, and you have to write the half of the coefficient of x. So what is the coefficient of x? Is here 1. So half, so it has to be divided by 2. So that is 1 by 2. Okay, 1 by 2, and you have to write the whole square. In here you have to write minus, and this 1 by 2 has to be square, that is 1 by 4. Say, to make the completion of square, here you are having x squared plus x. Okay, this can be written as x squared plus, you have to take the half of the coefficient of x. The coefficient of x is 1. So it is 1 by 2. So what you have to do? X squared plus x plus 1 by 2. 1 by 2, half of the coefficient of x, that is 1 by 2. So you have to square and add and subtract. That is 1 by 4 minus 1 by 4. So see the first term, it is in the form of a squared plus b squared plus 2ab. Okay, so therefore it will be x plus 1 by 2 the whole square. Okay, if you expand, it is a squared is x squared plus b squared is 1 by 2 the whole squared is 1 by 4 and 2ab. 2 into x into 1 by 2. So that 2 and the denominator 2 getting cancelled, you are having x. So for these three terms can be written as x plus 1 by 2 the whole squared minus 1 by 4. So without writing the step, I have written x plus 1 by 2 the whole square minus 1 by 4. So the shortcut is, first you have to write the variable. What the sign here you are having, you have to write it and take the half of the coefficient of x, that is 1 by 2. You have to write the whole square minus, always you have to write minus here, and you have to square the term, that is 1 by 2. Square the constant, that is 1 by 2 the whole square is 1 by 4. Otherwise you can do, how you have to do, you write the first two terms, take the coefficient of x and square it and add and subtract. So the first three terms will get the a plus b the whole squared or a minus b the whole squared will come. Here you are having x plus 1 by 2 the whole square minus 1 by 4. You can write it directly or you can add and subtract the square of half of the coefficient of x. Then you will get the completion of square. So here I have written this 1 by 4 can be written as 1 by 2 the whole square. Then I'll go for the integration on both the sides. So integral dy by y minus 1 can be written as log of y minus 1. So you see log of y minus 1, and it is in the form of which one? Integral dx divided by x squared minus a squared. How it is? Integral, it is in the form of integral dx divided by x squared minus a square. So the answer is 1 by 2a log of x minus a divided by x plus a plus c. So integral dx divided by, so in the place of x you are having x plus 1 by 2 the whole square minus, in the place of a you are having 1 by 2. So it has to be substituted. So 1 by 2 into, what is your a? It is 1 by 2 log of, in the place of x what you have to write? X plus 1 by 2 minus, what is your a? A also 1 by 2 divided by x plus 1 by 2. In the place of x you have to write x plus 1 by 2 plus a is 1 by 2 plus c. That only it is written. 1 divided by 2a log of x minus a divided by x plus a plus log c. Here why we have written log c? C is a arbitrary constant. These two terms having log. So that's why it is easy for us to simplify if you write c as log c. That's all. So this 2 and this 2 getting cancelled. Log of plus 1 by 2 and minus 1 by 2 getting cancelled. So therefore x divided by half plus half is 1. So it is x plus 1 plus log c. So here log a plus log b can be written as log ab. So the c is multiplied with this term. And both the sides you are having log. So it is getting cancelled. So therefore y minus 1 is equal to cx divided by x plus 1. In the problem it is given that the, you see, find the equation of the curve whose slope is y minus 1 divided by x squared plus x and which passes through. So therefore the curve passes through the point 1 comma 0. So here we have found the equation of the curve. So we have written the expression in terms of x and y, that is the equation of the curve. So the curve passes through 1 comma 0. 1 comma 0 means x is 1 and y as 0. So when you substitute y 0, 0 minus 1 is equal to, what is your x? X is 1. So c into 1 divided by 1 plus 1. C by 2 is equal to minus 1. So c is equal to minus 2. C value has to be substituted in this equation. So minus 2x divided by x plus 1. That's minus 1, when you bring it to the right side it is plus 1. So 1 minus 2x divided by x plus 1. If you take LCM, so that is x plus 1 minus 2x. You see that here x plus 1 into 1. So that is x plus 1 minus 2x divided by x plus 1. So x and minus 2x is minus x. So plus 1 is positive. So 1 minus x. This x plus 1 can be written as 1 plus x. Okay, so we have completed the third problem and we are coming to the fourth one, the first subdivision. You see that dy by dx is equal to square root of 1 minus x square divided by 1 minus y square divided by 1 minus x square. So first time I have written the square root separately. Square root of 1 minus y square divided by square root of 1 minus x square. So here in this differential equation it is involved y and x. So we have to separate the y term separately and x term separately. So here dy should be in the numerator. This square root of 1 minus y squared will come in the denominator. Where dx should not be in the denominator, it has to go to the right side in the numerator, dx by square root of 1 minus x square. So this side you have y term and next side you will have x term. Integrate on both the sides. So it is the formula of sine inverse of y, which is equal to, this is the same formula, so sine inverse of x plus c. Coming to the second subdivision, y dx plus 1 plus x squared tan inverse of x dy is equal to 0. So here plus is there, so bring any one term to the next side. So y dx, when you bring it to the next side, it is minus y dx. And now you can, what you can do, you can separate it. So y terms, so dy is in the numerator, so tan inverse here these two are x term, so you will have only dy. So this side, what is the y term? Only y. Bring this y to this side, that is equal to minus, so dx should be in the numerator, bring this x term to the denominator. So now left side fully y term and the right side you are having x term, so integrate on both the sides. So if you integrate, you see that already I have told, if you can identify this as, so that is dx divided by 1 plus x squared into tan inverse of x. So if you consider tan inverse of x as f of x, what is the differentiation of tan inverse of x? That is 1 by 1 plus x squared. So it is in the form of integral f dash of x by f of x. Your f of x is tan inverse of x. If you differentiate 1 by 1 plus x squared, so that is the differentiation of tan inverse of x. If it's so, you can write the formula log of f of x plus c. So log of tan inverse of x. So if you can identify directly, it is in the form of integral f dash of x by f of x dx. You can write very well log of tan inverse of x. Otherwise, you have to do this step. So first tan inverse of x you have to keep as t. And if you differentiate this, 1 by 1 plus x squared is equal to t, if you differentiate with respect to x, dt by dx. Arrange it. Dx will go to the numerator in the left side. So dx divided by 1 plus x squared is equal to dt. Take this term alone. What is it? Dx by 1 plus x squared. Instead of this term, you can write dt. That is written. What is remaining? 1 by tan inverse of x. What is tan inverse of x? It is t. So 1 by t into dt. What is the answer? When you integrate, it is log t. What is your t? T is equal to tan inverse of x. In this way also you can write. Otherwise, you can write it is in the form of integral f dash of x by f of x dx is equal to log of f of x plus c. That also you can write. Okay. So we have completed the integration this. So we have to take the left hand side integration, that is log y is equal to minus, what is the integration of this term? This is log of tan inverse of x. So minus log of tan inverse of x plus log c. Okay, the minus when you bring it to here, it will become plus. It is in the form of log a plus log b. So it is log ab. And this side also you are having log, both the log getting cancelled. So therefore y into tan inverse of x is equal to c. Log a plus log b is equal to log ab. So the y and tan inverse of x is multiplied and both the sides log getting cancelled. So therefore y tan inverse of x is equal to c. Okay, so the next one, Coming to the third subdivision, sine dy by dx is equal to a and y of 0 is equal to 1. So first dy by dx is equal to the sign, when you bring it to here, it is sine inverse of e. So dy is equal to sine inverse of e into dx. So we have separated the variables and you are going to integrate. So integral dy is equal to integral sine inverse of a into dx. So integral dy is y is equal to sine inverse of a is a constant, integral dx is x plus c. We have found the solution. In that it is given y of 0 is equal to 1, that is x 0, and if you substitute x as 0 in y, you will get the y value is 1. So x equal to 0 and y is equal to 1. So in the place of y you have to substitute 1. Sine inverse of a, what is x? X is 0 plus c. So if you multiply with 0, this term will getting 0. So therefore c is equal to 1. If you substitute c is equal to 1, so here if you substitute c as 1, this 1 when you bring it to the left side, it is y minus 1 equal to sine inverse of a into x. So bring this x to the denominator. So y minus 1 by x is equal to sine inverse of a. Sine inverse, when you take it to the next side, it will become sine. So sine of y minus 1 divided by x is equal to a. That will be the answer. Coming to the fourth subdivision, dy by dx is equal to e power x plus y plus x cube into e power y. So first e power x plus y has to be written. So the power is it's a addition. So we can write this as e power x into e power y plus x cube e power y. From these two terms e power y is common. If you take it out, it is e power x plus x cube. So arrange the y term on one side. So e power y, when you bring it to the left side, it will be in the denominator. Here e power x plus x cube into dx. This dx, when you bring it to the right side, it will become dx in the numerator. So e power y, when you bring it to the numerator, it is e power minus y, and you have to integrate on both the sides. So if the integration of e power minus y with respect to dy is minus e power minus y, and if e power x, if you differentiate with respect to x, it is e power x plus x cube, x power 4 by 4 plus c. Okay, so bring this minus term to the next side. So e power x plus e power minus y plus x power 4 by 5 plus c, when you bring it to here, it is minus c. So minus c is a constant, arbitrary constant. So we can write this as c. So fifth subdivision, e power y plus 1 into cos x dx is plus e power y sin x dy is equal to 0. Okay, so bring this term to the next side. Here you have to group the terms of y and the x term separately. Here dy is in the numerator, so we have to bring the right side as y term and the left side as x term. So here cos x dx. Okay, what is the x term is here? Sin x. So bring the sin x to the denominator. Here minus e power y dy, and bring the y term, that is e power y plus 1. You have to bring it to the right hand side. So it is in the denominator. So now this side, left side, you are having x, on the right side you are having y. So you have to integrate on both the sides. So integral cos x sin x dx is equal to minus integral e power y divided by e power y plus 1 into dy. You see that in the denominator you are having sin x. What is the differentiation of sin x? It is cos x. So it is in the form of integral f dash of x by f of x dx. So the answer is log of f of x. So log of sin x. In the same way, the minus is here. E power y plus 1, if you differentiate, the differentiation of e power y is e power y. Plus 1, if you differentiate, it is 0. So the differentiation of this one is in the numerator. So it is in the form of integral f dash of x by f of x dx. That is log of f of x. So log of e power y plus 1. So both the terms having log. So the arbitrary constant also can be written as log c. So here bring this minus term to the next side as plus. So it is in the form of what? Log a plus log b. So it is log A into B, that is equal to log C. So log getting cancelled. So your answer is sin x into e power y plus 1 is equal to C. And coming to the sixth subdivision. So here y dx minus x dy cot of x by y is equal to n y square dx. So I have considered the term. So this y squared I have brought to the left side. It will come in the denominator. And cot of x by y, that is equal to n into dx. So it is in the form of the differentiation of u by v. That is the differentiation of u by v. What has to come? U by v. So if you use quotient rule, it is v squared and v du minus u dv. So in the place of u, now you are having x by y. If we have, how to differentiate? It is y squared y dx minus x dy. So therefore this term is exactly is here, y dx minus x dy divided by d squared. So this is nothing but the differentiation of x by y into cot of x by y, that is equal to integral n dx. So this can be arranged as cot of x by y. This is the integrand. We have to integrate with respect to the variable x by y. Okay, so that is equal to integral n dx. So here cot of x by y, the variable of integration is x by y. Okay, so therefore if you cot x into dx, how you can write, how you can integrate? Cot x into dx is log of sin x. Here the variable is x by y. So the integration of cot of x by y with respect to the variable x by y is log of sin x by y is equal to n dx. N is a constant. Integral dx is x plus c. So the log, when you bring it to here, it is e power nx plus c. So how it will be written? E power nx into e power c. E power c is a constant that can be taken as c. So sin of x by y is equal to c e power nx. Okay, coming to the seventh subdivision. dy minus x into square root of 25 minus x squared is equal to 0. So you take this term and bring this the left side term to the right side, it will become positive. So dy is equal to, the dx should be in the numerator. So when you bring it to the right side, it will be in the numerator. So this left side you are having x term, the right side you are having left side you are having y term and the right side you are having x term. So you have to integrate on both the sides. So integral dy is equal to integral x into square root of 25 minus x squared into dx. So you see now here you are having the formula integral f dash of x into f of x the whole power n into dx. Okay, that can be written as f of x the whole power n plus 1 divided by n plus 1 plus c. So you have learned this formula in 11th standard in the method of substitution. So first here you will have f dash of x and f of x the whole power n into dx can be written as f of x the whole power n plus 1 divided by n plus 1. You see now here you will have the term integral ax square root of 25 minus x squared into dx. You see, if you consider f of x as 25 minus x squared, so the square root, the power is 1 by 2. So n is 1 by 2. So if you differentiate 25 minus x squared, what has to come? The differentiation of 25 is 0 and the differentiation of minus x squared is minus 2x. But here you are having only x. So we have to multiply minus 2 and divided by minus 2. Okay, multiply and divided by minus 2. So this minus 2 is a constant. So we can take it out, minus 1 by 2 integral minus 2x into 25 minus x squared the whole power 1 by 2 into dx. Now it is exactly in the form of f dash of x. This is your f dash of x and your f of x is 25 minus x squared. The n is half. So therefore it can be written as 25 minus x squared the whole power half, n is half plus 1, that is 3 by 2 divided by 3 by 2 plus c. So using this formula, you see here I have written minus 1 by 2. Why so? This minus 2 when I have brought to the front. So it is minus 1 by 2. And minus 2x is nothing but the differentiation of 25 minus x squared. So minus 2x. F dash of x. This is nothing but f of x the whole power n. Your n is half. So if you integrate, you will get this answer. So what has to come? This 2 will go to the numerator and it is cancelled with this 2. So it is minus 25 minus x squared the whole power 3 by 2 divided by 3 plus c. So if you take LCM, so it is 3 will go to the left side. So it is 3y is equal to minus 25 minus x squared the whole power 3 by 2 plus c. So finally this 3c can be written as c. Okay. So we'll go to the 8th subdivision. What is that? X cos y dy is equal to e power x into x log x plus 1 into dx. So you take this term. We have to group the y term in one side and the x term in another side. So dy is in the numerator. So we have to bring the y term to the left side. So that is cos y dy. So here there is no y term. So here you are having only one x term. We have to brought it down to the right hand side. So e power x into x log x plus 1 by x into dx. You are going to split this as, you see the first term, e power x log x by x. So x getting cancelled. Here you are having e power x log x plus e power x into 1 is e power x by x into dx. So you see that left side you are having y term, on the right side you are having x term. So you have to integrate on both the sides. So integral cos y dy. Here you are having two terms, addition of two terms. So we can write the integration separately. So integral e power x log x dx plus integral e power x by x into dx. So we have to integrate this term by using the methods of integration by parts. So we have to use the integration by parts method. For that you consider this and you have to write the integration by parts method formula is integral u dv is equal to uv minus integral v du. Okay, so u has to be kept as log x and dv as e power x into dx, the remaining as dv. So if you differentiate u with respect to x is 1 by x. So du alone is needed. So 1 by x into dx. If you integrate dv, it is v. The integration of e power x is e power x. So you have to substitute in the formula. So integral, what is u log x and what is dv e power x into dx, that is equal to u into v. U is log x, v is e power x. So e power x into log x minus integral, what is p, e power x into 1 by x into dx. So we have integrated this term, but still you are having this integral part, let it be. So you are going to, this is the solution. So you take the first one, integral cos y dy. First you have to write, and instead of this term you have to write these two terms. What is the term? E power x log x minus, what is it? E power x into 1 by x. That can be written as e power x by x into dx. So instead of this term we have written these two steps plus integral e power x by x into dx. So you see both the terms or same within the integral symbol. One is in plus, another one is minus. So both getting cancelled. So on the right side e power x log x plus c. And here you have to integrate cos y. The integration of cos y with respect to y is sin y. So we have completed the eighth subdivision. Coming to the ninth subdivision, tan y dy by dx is equal to cos of x plus y plus cos of x minus y. Okay, so see that cos a plus b, what is it? Cos x plus y can be written as cos x cos y minus sin x sin y. Okay, cos of x minus y can be written as cos x cos y plus sin x sin y. So here in between what you have to do, both the terms has to be added. While you are adding, these two getting cancelled, you are having 2 cos x cos y. So it will come be brought into multiplication. Now you can separate the y term and the x term. So here dy should be in the numerator. So tan y dy, and here what is the y term? Cos y. So cos y has to brought it down to the left side, and here 2 cos x dx. So left side there is no x term, so you will have only 2 cos x dx. So you have to integrate on both the sides. So the 1 by cos y can be written as secant y. Okay, 1 by cos y, the reciprocal of cos y is nothing but secant y. So it can be written as integral tan y secant y dy is equal to, okay, what is in the right side? Integral 2 cos x dx. So it is the formula of, what is the formula? Integral secant x tan x dx is equal to secant x. The integration formula is secant, here y is involved, so it is secant y is equal to 2 is a constant. The integration of cos x is sin x plus c. Okay, and coming to the 10th subdivision, dy by dx is equal to tan squared x plus y. It's an important problem. So we can't split x plus y. So we have to consider x plus y as some other variable z. So differentiate with respect to x. So the differentiation of x with respect to x is 1, and if you differentiate y with respect to x is dy by dx. Z also another variable, so if you differentiate z with respect to x is dz by dx. So from this your dy by dx is what? Dz by dx. The plus 1, when you bring it to the right side, minus 1. So we have brought dy by dx. So take the question, in the place of dy by dx, you can substitute dz by dx minus 1 is equal to, what has to come? Tan squared z. Now your differential equation involve z and x. Okay, so dz by dx is equal to minus 1, when you take it to the right side it is plus 1. So 1 plus tan squared z. Okay, so this is the z term, you bring it to the left side in the denominator. Here in the dx, when you bring it to the right side, it will be in the numerator. dz and dx should be in the numerator alone. Okay, so here one side, the left side you are having z term, and the right side you are having x term. So integrate on both the sides. So 1 plus tan squared z. Tan squared z can be written as sin squared z by cos squared z. Okay, if you take LCM, it is cos squared z plus sin squared z by cos squared z. This cos squared z is in the denominator of the denominator. After taking LCM, it will go to the numerator. So the next step will be cos squared z dz divided by cos squared z plus sin squared z. So what is cos squared z plus sin squared z is 1. So you will get this term. So here you are having the power 2. So what you have to do, you have to use the trigonometry formula 1 plus cos 2z by 2. So cos squared z, the formula is 1 plus cos 2z by 2. Trigonometry formula is applied, is equal to integral dx. This 2 will go to the front, that is 1 by 2. It's a constant, it is taken out. The numerator, first term is 1. 1 into dz. If you integrate, that is z. Plus second term cos 2z into dz. If you integrate, it is sin 2z divided by 2. because the coefficient of z is 2. So it has to return in the denominator. So sine 2z divided by 2 is equal to, what is the integral dx is x plus c. Okay, so this 2, if you take it to the right side, it is 2x plus 2c. Okay, so here remaining is this term. So we have to write the answer in terms of x and y. So z can be written as x plus by y, because we have taken your z as first starting, it is x plus y is equal to z. So in the place of z, you have to substitute x plus y plus sine of 2 into x plus y by 2. It is equal to 2x plus 2c. So x plus y, it is in the form of sine 2x. Sine 2x, trigonometry formula is 2 sin x cos x. So in the place of x, you are having x plus y. So 2 sin x plus y cos x plus y divided by 2. This 2 getting cancelled. That is equal to 2x plus 2c. So if you bring this x to the right side, it is 2x minus x is x. See x, here you are having 2x. So when you bring this x to the right side, it is 2x minus x. So 2x minus x is x plus 2c. This 2c is a constant, we can take it as c. So the answer is y plus sine of x plus y cos of x plus y is equal to x plus c. Thank you, students.